Optics is the study of light, and light is one of the most fundamental things that all of us experience. It comes from the sun, it's the source of our energy, it is the source of the very energy inside the atom. On a very practical way, however, we use the technology of light in lasers for communications, for medical imaging, for research that is uncovering how to create sustainable energies, as the sun does, and also to use it to communicate with people around the world. We started the company here in Connecticut, and we now have 22 employees, and our manufacturing and R&D facilities are located here in Durham.
내 맘에 얹은 두 손 살며시 뿜는 미소 내 맘에 잠든 그 몸 살며시 숨죽이고.
Most people, when you talk to them and they say, what do you do? And you say, I make mirrors, the first thing that comes in your mind is you make like car mirrors, or you make, bathroom mirrors, or if you say you make optics, people think like eyeglass lenses or something like that. But the optics that we make are utilized in tons of applications, whether it be from the Google cars that drive themselves in major cities to missile guidance systems for governments, to satellites, to forward-looking infrared systems that are used for search and rescue in the military. Like when you work in optics, you get to see your projects distributed all throughout the world in applications that help protect not only things that you feel are important, but also everyone else, you know what I mean?
Yes. Remember the drawing for GSI? So now he wants it to be 22.
I always tell people that optics is a pretty science. It's a pretty branch of engineering, and you don't have to deal with soil, cables, nothing. You're pretty much working with light. How clean can that get? Can I get cleaner than that? It's pretty. A big part of the budget the government assigns to science goes into aerospace science. If you do not have precision mirrors and precision optical technology that goes into telescopes, then, how do I say this? Then there will be no advancements and there will be no discoveries of the universe or anything like that. All satellites or telescopes that go into space need optics, and we make those optics. That's why I think the optics field is important.
Like to get a quote on an off-axis parabola. My window here at AOS is kind of small. I work specifically with the financial end of things, bookkeeping and accounting and HR, employees and some of their personal information and vacation time and things. So I rarely get to see the complexity or understand the complexity of the design and the products that we put out here for our customers. So I enjoy when I get to sit in on a projection meeting of goals or visions, or maybe an update from a recent trade show, and get to hear what is actually happening here. And I think one of the unique things about this company is that we're in a tiny little town in Durham, Connecticut, and yet we have customers around the world. And it's neat to think about some of the little numbers and different things that I'm working with might be having to do with a customer that's in France or in Germany or some other place around the world. So I enjoy getting to hear some of those meetings, because then I get to see the big picture of what's going on here.
When I was in high school, I was fascinated by cameras and imaging, telescopes, and lasers. And I didn't fully understand the careers that were available in this area, but the technology itself gave me some direction. And I went to school to study optics, and as I studied, I also had to work. So I was able to work in a laboratory at the university that was making optical components for high energy lasers. And now, almost 30 years later, I'm still working in this field. So this is where it all started. In 2005, I started an engineering services company out of the room above our garage, and started working with clients overseas, advising them in manufacturing of optics. I became something of a problem solver for the companies I began working with. And then those contracts grew into technology development projects, and later my clients began asking me to help them find international partners that would help them expand their business. As I was growing up as a kid, my father worked as a salesman, but was really unsuccessful in his desire to become independent, to work for himself. My mother was trained as a nurse, and by the time she was in her mid-30s, she began showing symptoms of multiple sclerosis. So her ability to work very quickly eroded. However, even in that state, she decided that she would start her own business as an independent distributor of healthcare products, and she did this as long as she could. For me, after I got out of college, I worked for a well-known optical company for 15 years, and then I decided now it was my turn to see what I could build. One of the first technology development projects that one of my Japanese clients, Okamoto Optics, asked me to assist them with was in building a measurement instrument. They had just been selected by the Institute of Laser Engineering at Osaka University to help them upgrade their high-energy laser system. This is a laser system used for generating fusion reactions. And the optics were quite large, much larger than what they were able to measure. So they asked me if I would help them to build such an instrument. And that became the first major technology development project. Shortly later, my consulting business began to become more technologically involved. So we had to move the cars out of the garage and create a laboratory, a prototyping laboratory in our garage. And this is what eventually grew into what is today Aperture Optical Sciences. People often say that, oh, it must be so nice working for yourself, not having a boss and being able to choose your own working hours. Well, one of my friends who's also an independent businessman responded to that question by saying, yes, you get to choose which 22 out of the 24 hours a day you want to work. Another struggle is growing a company from just a single person and a good idea into a business that is larger than any one person. And Aperture Optical Sciences now is 22 people, not just one person, and needs to embody the creativity and the passions of far more than just one person. My desire for Aperture Optical Sciences is that it will be a vehicle for people to develop their creative talents, for them to see what they have inside and then exploit all the potential that they have. And when I can help people to do this, then we will truly be an engine that will fuel the innovations for the next century.